Hello everyone and welcome to this new project. In this project, we're going to learn how can we detect faces in images, and we're also going to learn how can we detect eyes in images too. It's actually really fun project because you can actually apply it and maybe upload your own picture and see how can you detect, for example, your face, or maybe upload your family picture, for instance, and see how can we detect the entire families like faces, and we'll also be able to see and detect eyes too, which is really fun. All right, let's get started. So in this project we're going to have kind of three parts. So the learning outcome one, we're going to learn how can we detect one face, just one single face in an image. And then afterwards we're going to learn how can we detect multiple faces or more than one face in an image. So think of it, there might be 4 loops in there and we might detect more than one face. And then learning outcome 3, we're going to detect eyes and faces too. So within that face, I'm going to go inside and actually try to extract information related to the eyes too, which is really fun. All right, so the first step is, okay, what images are we looking for? So in the course package, okay, let's actually go back here. So in the course package, you will find that there is 2 JPG images, okay? One of them is called Scientist and the other one is called Trudeau. Let's open Trudeau one. So this is basically the image of Justin Trudeau, the Canadian Prime Minister as we speak. And he's one of my favorite politicians actually. So we're gonna see how can we apply kind of, like artificial intelligence in a way, and to just go ahead and detect, this specific face. And then afterwards, we'll see how can we detect the eyes as well within this image, okay? This is the first step. And then afterwards, there is another image. It's called Scientist. Let's open it. And these kind of, one of my favorite, images of all. These are kind of, a list of all the scientists basically you would have here. And we'll see how can we apply, kind of face classifiers to actually go ahead and detect all these faces within the image. Okay, it's pretty interesting, pretty fun too. All right, so that's kind of the 2 inputs. Another input that we're going to have as well is what we call it the HAR Cascades classifiers, okay? So this is a folder here, it's called HAR Cascades. If you open it, you will find that there are 2 files in there, XML files. Okay, here, this course is not about an entire artificial intelligence, machine learning course, but the overall idea here, and that's what I want you guys to know, is that these 2 classifiers here, this is kind of, think of it as 2 trained models. So these are models that have been trained already. Okay, they have been, like already taken care of. What we're gonna do here, we're just gonna use them in practice. Okay, this is specifically used for eye detection. So if you send it to any image, it should detect eyes into it. Here, this is what we call it frontal face. Once you use it, it will simply gonna detect basically faces. All right, so within any image, it's already trained beforehand using multiple images to actually detect certain image within a picture. Okay, that's detect certain face within an image. My apologies. That's pretty much all what we need to know. Okay, that's overall information that we're going to be using throughout this project. Okay, and that's pretty much all what I have for this lecture. Just a quick overview of what we're going to be doing. Let's get started. In the next lecture, I'm going to walk you through the learning outcome 1, which is how can we detect a single face. Best of luck and see you guys in the next lecture. Hello everyone and welcome to this lecture. In the previous lecture, I walked you through a quick overview of the files, what we're going to be doing, and let's get started right away and let's detect one single face. Let's see how can we do that. All right, so first of all, let's go ahead and import our important packages. Okay, so we're going to import NumPy as NP, and we're going to import OpenCV, which is CV2. Okay, and we're going to import OpenCV, so we're going to import CV2. If you guys, please go ahead to the setup lecture and try to see how can you install OpenCV. Okay, and I'm gonna have a lot of detailed instructions on to how to install OpenCV in there. Okay, let's press Shift Enter. If you have it installed, you have no problem, no error will gonna appear here. All right, the next step is what I want you guys to do is to simply go ahead and read one single image. So what we're going to be doing, we're going to be detecting one face. So if you guys remember in the course, actual course package, you'll find that there is two images here, Trudeau and Scientist. So what I wanted to do is to read the Trudeau image, and that's the main image we're going to be working with in this learning outcome, this section. So let's get started. So let's actually zoom in a little bit, if you guys are able to see it very clearly. So let's go ahead. So we're going to say, okay, CV2 dot image read, and here I just need to pass my image. So the name of the image is Trudeau dot JPG. That should read the image, and I'm gonna take it and put it in image C. It stands for color. So this is a colored image. All right, Shift Enter, looks great. Let's go ahead and actually visualize this. Go ahead and see it. So we're gonna use OpenCV as well to visualize the image. So we're gonna say CV2 dot image show, and here I need to specify the title for the image. So here I called it, let's say, Trudeau face. You can call it whatever you want, and actually I call it in color because it's colored, and I'm going to specify comma, and here I need to pass along what image I need to be printing. So I can copy this and paste it here. Okay, please do not go and run this, okay, because if you run it, you're going to get into loops, and then the kernel will crash. In order to do this, like with OpenCV, you have to include these two lines as well. So we're going to say CV2 dot wait key, okay, and then afterwards we're going to say CV2 dot destroy all windows. Actually, if you press tab and it will auto-complete, and we say destroy all windows. Okay, simply put here, when we put these two lines because once we show the image, okay, you will find that here it's kind of the code is actually kind of stuck in a loop, right? So in order to exit that loop, we're going to be waiting for a specific key. So if you enter any key, once you enter any key, it will destroy all windows. We're just going to destroy the image, okay? Just going to hide the image again, and that should be able to exit that loop and keep going and actually run the next cells. Okay, let's go ahead and give it a shot. I'm going to press Shift Enter, and here we go. So first step is, this is our image, right? Actually, let's go back. I don't know why I did this. So if you guys take a look here at our kernel, you'll find that there is asterisk here, which means that we're stuck here. The program is just waiting for you to provide something, provide an input, do something, okay? So again, this is the image. This is, again, we're stuck. If you press Enter, you'll find that here the asterisk is gone, and we destroyed all windows. The image is gone already. It's it's like Snapchat in a way. All right, okay, looks good. Let's go back here. All right, so the next step is what I want you to do, kind of quick exercise. We're gonna go ahead and actually convert that image into grayscale and visualize the image again. So to do that, we're gonna say, okay, image underscore gray equals to CV2 dot CVT color. Please make sure that C is uppercase. And what we're going to do here, we're going to pass along our image color, which is our colored image in here. And we have to specify what do you want to do with it. We're going to say, okay, CV2 dot. Actually, if you press tab, it will show you tons of information here. These are kind of, everything you could do. You can normalize image. You can do aspect ratio. You can do focal length, like tons of stuff. You need like I don't know, like 10 PhDs to actually go through all these stuff. There is tons of information here. We don't care about all this stuff. We just wanted to convert from a colored to grayscale. So we're going to say, okay, I'm going to say color underscore BGR, which stands for blue, green, and red, to gray. And that's what we wanted to do. We want to convert from colored to grayscale. That's what we want to do. And this simply will just gonna convert our image color into our image gray. Okay, and what I'm gonna do, we're gonna copy these two. Actually, I'm gonna copy the entire thing here and paste it here. And I'm gonna do Trudeau face in grayscale because I wanted to plot the entire image in grayscale. And instead of image underscore color, I'm gonna say it image underscore gray. Okay, that should plot simply our image gray here. We're going to do the exact same wait key and destroy as well. All right, okay, looks good. Shift enter. All right, it will tell me that, you know, like this module is not defined. So CV2, CVT color. Actually, this has to be all uppercase. My apologies. So we're going to say this all uppercase. So color underscore BGR to gray. Please make sure that these two are lowercase, CV2 2, and then this has to be all uppercase. Shift enter, looks good. Okay, now there's no error, the error is gone. Shift enter, and here we go. So if you actually go here, you will find that this is my grayscale image, okay? And looks good, that means the function actually worked. And if you go back to our step here, you will find that you are stuck in a loop, right? So in order to exit this loop, let's go back to the image and press enter, and that should exit our loop in here. All right, looks great. So that's pretty much all what we need to know right now at the moment. Just in like, how can we actually just load an image, convert it from color to grayscale, and actually plot our image. Okay. All right, and what we're gonna do here, I'm just gonna conclude this lecture at this step, at this stage. And in the next lecture, I'm going to show you how can we start to actually like take our face classifier and start to detect specific faces. But before we do that, what I want you guys to do here is for that mini challenge, I want you guys to insert a couple of new cells in here. And I want you to, instead of reading Trudeau image, I want you to read the other image, which is what we have here provided, which we call it scientist image, and convert it to grayscale as well. Please go ahead, pause the video, and I will see you guys after the challenge. All right, I hope you guys were able to figure out the challenge. What I ask you guys to do is simply, instead of having Trudeau.jpg, I just wanted to have scientists instead. So we're gonna say, okay, scientists. I hope it is exactly the same, scientists. There's an S at the end. So here we're just gonna add S. All right, and that's it. So let's run it, run it, run it. And here we go. This is the image of all the scientists, right? Again, we're stuck in a loop. Press enter. Again, it's colored image. Here we convert it from color to grayscale. And here we go. This is our grayscale image. Okay, okay, looks good. Shift enter, looks great. All right, and that's it. Let's go back to actually our image again. Trudeau. Okay, make sure that's actually functioning properly. Looks great. Let's go back here, run this, looks great. And here we go. All right, that's pretty much all I have for this lecture. I hope you guys enjoyed it. In the next lecture, we're gonna go ahead and actually start to classify and detect faces. Best of luck, and I will see you guys in the next lecture. Hello everyone, and welcome to this lecture. In the previous lecture, we were able to load specific images, okay, which is Trudeau image. And we're able to actually convert that image from color to grayscale. In this lecture, let's get started and see how can we apply our face detection algorithm to actually extract the face and actually locate the face. Let's see how can we do that. First of all, let's go ahead and import our what we call it Cascade classifier. Again, this course is not about, you know, like machine learning or artificial intelligence total course. There is a section on our machine learning and artificial intelligence, but it doesn't go a little bit deeper to actually how can we perform, you know, all the training, for example, for using Cascade classifiers, which is kind of an advanced computer vision techniques. What I want you guys to know here that we have trained model already obtained in there, okay? These models are already trained. It's kind of, you know, like in here it's called HAR Cascades. They have already trained XML documents that contains HAR Cascade Eye, which is simply just can be used to detect eyes within any image. And this one is what we call it HAR Cascade Frontal Face Default that can be used to actually detect just faces within an image, okay? So we have one that detects faces and we have one that detects eyes. That's pretty much it. What we're gonna do, we're just gonna import that Cascade classifier. That's it, we're just gonna use it in practice. Let's go ahead and see what we can do that. We're gonna say, okay, face underscore detection equals to cv2 dot cascade. And if you actually press tab, it will show you there's Cascade classifier. And then here, we need to just specify the path of our of our classifier. So here, because I'm detecting faces, I'm going to say, okay, har cascades, and then I'm going to pass along here our har cascade underscore frontal face underscore default dot xml. And if everything works, you should have no problem. So when you press shift enter, it looks good. So pretty much now we have kind of, think about it, that now we have a kind of a trained model called face detection. You can use it right away, deploy it in practice to detect faces within images. Okay, so how can we do that? What we could do, we're gonna say, okay, please, could you please give me the faces? Give me, what's gonna happen here, we're gonna return all the coordinates of the face. So in Trudeau's image, for instance, we're gonna turn me, okay, we're gonna return kind of a rectangle around his face. So we're gonna do here, we're gonna say, okay, faces equals to, we're going to get our face detection in here, paste it. And what we're gonna do, we're gonna apply kind of a method called detect multiscale, Actually, if you press tab, it will show you under face detection, there is a detect multiscale. And what I need to do simply here, I just need to pass my image underscore color, which is my Trudeau's image here in colored format. Okay. And here I need to specify just two numbers. I'm going to tell you exactly what I mean by these two numbers. Here, let's say I'm going to say 1.1, and then I'm going to say 5. All right. So what do you mean by this? So actually try to include here the information for you guys. So when we apply Cascade classifier or face detection classifier here in this case, detect multiscale, you will find that we pass along our input image, which is here image color, and we pass along kind of two parameters. The first one is what we call it scale factor. The second one is what we call it min neighbors. Okay, what do you mean by this? Again, it's very, very simple. Might look a little bit intimidating, but it's very simple. So the first one is what we call a scale factor. The overall idea is that we wanted to kind of scale our image. Just think of it as taking just one image and make it, you know, like smaller versions out of it and larger versions out of it. And this kind of process, what we call it in computer vision, we call it pyramiding. You're kind of creating like a different pyramids. Think of it, you know, the pyramids, you know, in Egypt, for example, we have like three kind of, you know, like copies of them, right? We have like a large, you know, the pyramid, and then there's an intermediate one, and there's a smaller one. They are all pretty much have the same features, right? They all look like a pyramid. They have the same color, pretty much the same thing, but just different sizes. That's the overall idea. So scale factor, simply when I say 1.1, that means we're just gonna rescale the image and, you know, kind of reduce it to 10% of its size. When I say, let's say for 1.2, it means image is reduced by 20% each time it's scaled. That means I'm gonna take the image, I'm gonna reduce it, let's say by 20%, and run the classifier again, and then reduce it again by 20%, run the classifier again, and so on. So when I say 1.2, that means each step will gonna be 20%. When I say 1.1, that means each step will gonna be 10%. All right? So think about it here. If once we go, let's say, smaller and smaller, let's say to 1.05, for example, that means 5%. It will take much longer time, because that means I'm taking the original image, I'm rescaling it several times, just creating multiples of them. Why am I doing this? I'm doing this because the classifier was trained on a specific size of the image. What I wanted to do is simply, when I plot, let's say, Trudeau's image, let's actually show it. I wanted to create the classifier to, for example, look at faces in here, and then look at faces in here, look at faces in here. That's what the classifier is doing, just scanning through the entire image and trying to look for a face, right? So for example, if my face is smaller, let's say here, for example, if like a little kid in here, for example, in here, right, the face might be smaller, right? So what I need to do, then I need to take the image and scale it into different multiple scales. That's the overall idea. Take the original image and rescale it into smaller ones just to try to look for a face, simply. Okay? Okay. That's first step. The next step is what we call it min neighbors. And this parameter is used to specify how many neighbors each candidate rectangle should have to retain it. Think about it as kind of, you know, like how many times I'm going to be able to detect faces. So let's say here, I'm going to, again, let's open our Trudeau's image. So let's say I detected, for example, in here, I'm going to detect one face, and then I'm going to shift my rectangle a little bit, right? And they're going to say, okay, I detected another face, and then one more time, I detect another face. So let's say once kind of, in the neighborhood of these pixels, I detect, let's say, 5 times faces or 5 faces, okay? Then I'm gonna say, you know what, that's an actual face. Why? Because there's a repetition. That means, like a lot of pixels, a lot of, classifiers, when I scan through the images, a lot of neighbors within that neighboring area, it says, okay, you know what, there is a face there. That's the overall idea, okay? So the numbers generally range from 3 to 6. The parameter will mainly affect the quality of the detected faces, and higher values will result in less detections, but with higher quality. Simply put, if you set high values, if you set, let's say, for example, that number, set it to 10, for instance, that means I need to have at least 10 neighbors, they say that there is a face there, right? Which will gonna reduce kind of the false positives. However, if you set it to, let's say, 1, you might have kind of, like a lot of wrong, for example, estimates. So you're gonna say, okay, maybe there is a face there, maybe there is face there, because I'm relying on one single point, right? But if I have kind of maybe 3 to 6, that should add more fidelity in there, and I'm not gonna be detecting, random faces somewhere. All right, let's go ahead and run this command. So run it, and here we go. So now what happened is I have been able to detect all the faces, which is really powerful. If you think about it, we don't need to learn any artificial intelligence or computer vision or whatever. Just apply this. It has all the smartness in there. You literally can create an app right now, because now in the faces here, actually, let's take a look at faces. Control V. Here we go. It will just tell us these are the coordinates of the face. Okay, so again, it's not that simple. It's just going to show you what they mean by all these coordinates, but the overall idea that, this function told me, okay, you know what? I have detected one single face, and here you go. These are the pixel locations of my face. All right, it's really, really amazing. All right, so what are these? What are these numbers? So let's go ahead and actually visualize these numbers. So let's go ahead and run the face here. So you'll find that there are kind of certain numbers here: 3321, 121, 208, and 208. Okay, what's happening here? All right, so the first 2 numbers, these are the coordinates of the top left rectangle index or corner. All right, so what happened is the detect faces will gonna detect a rectangle here around the face here, right? Okay, so in that rectangle, in the top left corner, this is simply our coordinates. So what this is saying, okay, if you go here to, this is the X and this is the Y. So X is, and my apologies, if you go back here to the image, please note that this point in here, this is 0 and 0, okay? I don't know why it's doing this. So this point, again, is 0 and 0. Please don't get confused. Again, it's very, very simple. This is our origin, okay? This is when we move to the right, that means we're going X direction. When we go down, that means we're going to the Y direction, right? So when I say I went here, let's say, for example, 332, so I moved to the right 332 pixels, okay? Okay. The next point here was, if you go down, the next point was 121. All right, what does this point mean? This point is the Y coordinate of the top left corner of my rectangle. So what I'm saying is this 121 point is I go down here 121 pixels, and that's what I'm getting. Basically, I'm stuck here. This is the coordinates of the point of the first rectangle that has been detected, which is only one rectangle. All right. Okay, this looks great. What about the other 2 numbers? What about 208 and 208? If you actually go back here, you'll find there is 208 and 208. 208 and 208 are simply the dimensions of the width and height of my rectangle. So now I have the corner, right? Now I need to know how far I need to go east, right here, which is 208, and how far do I need to go down, which is here 208. It looks like, it's basic, it won't be a rectangle, it will be kind of a square, because we're going to be drawing here kind of a square with 208 dimensions for both sides. That's it. That's pretty much all what I want you guys to do. Press shift, press enter, or press whatever key, and let's go back here, and here we go. All right, so let's go ahead and actually name them. So we're gonna say, okay, let's take a look at faces, and let's go ahead and grab, for example, 1. So if I say faces of 1, shift enter, that will give me 1 to 1. If I say faces of 0, that should bring me the first element within my NumPy array, which is, you know, like 3, 3, 2, 1. Again, this is index 0, index 1, index 2, index 3, right? Let's actually make that bigger. And let's zoom in a little bit. Okay, so faces 0, faces 1, faces 2, let's take a look at it, and faces 3 as well. Okay, 208. If I made faces 4, it will tell me, oh, well, I don't know you because index 4 is out of bound. This is index 0, 1, 2, 3. All right, okay, looks good. All right, so what I want you guys to do, and that will be our mini challenge in here, shift enter. I wanted to simply take these faces and name them like this. I'm going to say x equals to something, y equals to something. X is the coordinates, x coordinates of my top left corner within my rectangle. Y is the y coordinate of my top left corner of my rectangle. And then I'm going to say my width of my rectangle and my height of my rectangle equals something. Okay, obviously it will gonna be faces of something. Please go ahead, pause the video, and try to fill out here what do you mean by x, y, w, and h. It's just simply renaming of my faces array here into a bunch of variables. Please go ahead, pause the video, and I will see you guys after the challenge. All right, I hope you guys were able to figure out the challenge. What I ask you guys to do is simply go ahead and assign faces of all and 0, which is my first element here. It's 3, 3, 2, 1. That will be my x coordinate, right? And then I'm going to go ahead and take faces of all and 1, and that will be my y coordinate. And then I'm going to have faces all and 2, which is going to be my next coordinate. And then I'm going to have faces all and 3, which is going to be my last coordinate in here. Press shift enter. Here we go. Now I have x, y, w, and h. And here we go. Now I'm pretty much ready to go ahead, leverage these coordinates, and actually draw a physical rectangle around the image. Let's see how can we do that. What we could do, we can say, okay, in OpenCV, if we say cv2 dot rectangle, if you actually press tab, it will show you there is a recover pose, there is rectangle, reduce, remap, repeat, tons of stuff here. I wanted to draw a rectangle, so I'm going to say rectangle. Okay, where do you want to draw the rectangle? I wanted to draw a rectangle. Actually, if you press shift and tab, it will show you here how can you draw a rectangle. It will tell you, okay, you need to pass along your original image. You need to pass along here point 1 and point 2. So I need to pass along 2 points basically, where point 1 and point 2, actually if you go up, if you go down here, these are kind of, you know, like tell you the opposite corners. So I need to specify the dimensions of the 2 opposite corners. Top left corner and bottom right corner. Let's see how can we do that. Okay. First, I need to pass along my image. So my image is contained in here, which is image color. Let's copy that. Let's paste it here. And let's go ahead and actually specify my coordinates. First, I'm going to say, okay, I need my top left corner, which is simply my x and y, if you guys remember. So I'm going to say x, and y. That's my first point, or point 1. And I need to specify the coordinates for point 2. So if you guys remember, point 1 is top left corner, point 2 is bottom right corner, right? So simply, if I take my x value and add it to it, my width, which is 218 or 208, that will give me the other point or the other x coordinate. And if I do the same thing as well, if I say y plus h, if I take my top left point and I added the height to it, which is 208 as well, that should bring me down to the bottom right corner. Again, if you guys can't visualize it, let's go ahead and do it here. So what's happening here is I have this point, right? So I have x and y that indicates the top left corner within my rectangle that I'm going to be drawing here, right? What I need to do, I need to specify this is point 1. Here I need to specify point 2, right? To do that, I'm going to say, okay, let's take x and add width to it. Let's take y, okay, which is I have here. Apologies. Let's take y, which is this point, the coordinates of y, and let's add height to it, which is 208 as well. That will bring me down to this coordinate. That's the overall idea. If you guys are a little bit confused, don't worry about it. I'm going to show you exactly when we actually plot the rectangle, what do you mean by this. Afterwards, I need to specify the color. Okay, what's the color of my rectangle? So I'm going to say, okay, 255, you can call it whatever, 255, that indicates, I believe, a yellow color, and we'll see what is that. And then here I'll specify the thickness of my rectangle. So I'm going to say, okay, thickness is, let's say, 3. All right, okay, looks good. So now I draw a rectangle. Let's go ahead and use OpenCV as well. So I'm going to say cv2.image_show. And here I'm going to say, okay, single face detection, because I'm detecting single face. And I need to visualize image C, which is the image along with the rectangle drawn on it. And please don't forget to add cv2.waitKey. And please don't forget to add as well our cv2.destroy all windows. All right, looks fantastic. Shift enter. And here we go. All right, it's actually open in my next window. Here we go. This is our beautiful rectangle in there. All right, so if you guys take a look at it, you will find that we have been detecting the top left corner, which is x and y coordinate. And this is simply the point that has x plus w, or x plus width, and y plus the height, which is this point. All right, that's it. Amazing. So that's pretty much all what I have for this lecture. What I want you guys to do is please go ahead, another mini challenge, pause the video and pass along here, instead of the yellow color, pick any other color. Okay, so just pick whatever color you wanted here, and here change the thickness from 3, let's say, to 6, for example, maybe 10, and please let me know what you guys notice. Please go ahead, pause the video, and I will see you guys after the challenge. All right, I hope you guys were able to figure out the challenge. What I ask you guys to do is simply pick any color. So maybe I'm gonna set this to 0, for example. That will give me another color. And here instead of 3, I'm gonna make it, let's say, 6. And let's take a look what's gonna happen here. Shift enter, and here we go. Now it became red, okay? And the thickness here of the line becomes a little bit different. Let's actually make it maybe 10, for example. Shift enter. Here we go, the line became more thick. And here we have, again, the red color. Maybe go here and make it all, let's say 255, believe. Let's go ahead and 255 and make this maybe 20. Shift enter, here we go. Now 255, 255, 255 indicates white. And the rectangle here becomes way thicker. Obviously it looks weird. So let's go back and maybe set it back, let's say to 255, 0255, and set this to 10. Shift enter, here we go. Actually it plotted on top of it. So let's go back, and so every time I'm doing this, I'm basically taking my image color and I'm adding to it, right? So if you repeat the entire thing from scratch, let's go ahead and run it. So now I loaded a new image, right? So let's do the grayscale too if I wanted to. Okay, looks good. Keep going. Cascade classifier, detect multiscale, go to the faces, define the coordinates, and do the detection, and here we go. All right, okay, so only have one rectangle that has been drawn, and with the thickness of 10, and with that specific color. All right, that's pretty much all I have for this lecture. I hope you guys enjoyed it. In the next lecture, what I'm gonna do is I'm going to walk you through my learning outcome 2, which is how to detect multiple faces. It's very interesting. We're gonna take another image and see how can we detect multiple faces. And then the next lecture, I'm gonna show you how can we detect the eyes and faces as well. Best of luck, and I'll see you guys in the next lecture. Hello everyone, and welcome to this lecture. In the previous lecture, we were able to detect a face, and we actually applied it to detect Trudeau's face. Let's go ahead and actually run it, and let's take a look at it. So press Shift Enter. Here we have the face. We're able to actually convert from color to gray, okay? And we're able to obtain image underscore G, stands for image underscore gray. Shift Enter, here we go. This is a gray image. And here we're able to actually run our Cascade classifier. just load it first, and then use detect multiscale on our image to return back the coordinates for our face. Shift enter. Here we have all our coordinates for our face, and then here we realize that we have got the coordinates of the face, okay, which is x and y coordinates for the top left corner point, and here we have the width and height, and here we're able to actually draw the actual rectangle on Trudeau's face, and that's the first step in our project. The next step is we're going to learn how can we detect multiple faces, not just one single face. So let's see how can we do that. First of all, actually we're going to do pretty much the same steps as before. So let's see how can we do it. We're going to say, okay, image underscore color equals to cv2.imageRead. And what I'm going to do here, instead of reading Trudeau's, I'm just going to read scientists. Actually, if I press tab, because the image is contained within the same folder, we're just going to load it here. Looks good. Shift enter. If I wanted to take a look at it, I'm going to say cv2.imageShow. And here I need to call it something. So I'm going to say, okay, scientists in color. And I'm going to pass along my image underscore C. Oh, my apologies. Okay, I actually asked you before never to do that. That's my bad. So if you actually do that, you'll find that you come up with this image, this figure showing not responding, and the kernel will crash. And please don't do it, like I did right now. Let's close the program. Okay. And in order to do that, in order to avoid this, okay, so we're going to restart. Please restart. We need to make sure that we have cv2, the await key, and destroy all windows as well whenever we use cv2.imageShow. Okay. All right. Let's actually run it again. So it's going to tell me cv2 is not even defined. So let's go ahead and define OpenCV. Shift enter. That's good. Let's go ahead and load it. All right. Here we go. That's our image, basically, of all the scientists in color. So, and the image is still running. If you guys can see, the kernel is still running. So let's go ahead and press whatever key, enter, for example, just to exit. All right. Let's go ahead and actually apply more than one face detection. So for what I'm going to do, we're going to say, okay, face underscore detection equals to, we're going to say cv2 dot cascade classifier. If you press tab, it will show you Cascade Classifier. And then what we could do here, we could say, okay, har Cascades / har Cascade underscore. Actually, if you press tab, it will autocomplete. Okay, so it found frontal face, the default XML. Shift enter, looks good. And the next step, so what we could do here, we could say, okay, let's go ahead and use face detection multiscale to actually return my faces. So we're going to say faces equals to face detection dot detect multiscale. So we're going to tell you again, tab detect multiscale. We're going to pass along our image underscore C, and we here specify, let's say 1.1 and 5. If you guys remember from previous lecture, that 1.1, this will just like rescale the image every time at 10% of its value, just to try to find every single image, every single face basically in our image. And here when we say 5, that means I need to have 5 neighbors detect. To simply detect 5 images. To simply detect 5 faces kind of next to each other to make sure that this will gonna be kind of, like a positive or a face that has been detected. All right, okay. Press shift enter. It's taking a little bit of while. That's good sign. Okay, and then we can go ahead and instead of just plotting one face, what I need to do, I'm gonna say, okay, let's go ahead and actually create a for loop. So I'm gonna say for. Every time I'm gonna say, gonna return x, y, width and height, and I'm gonna go into faces. So here faces contains simply every single face that has been detected, right? So what I'm going to do here, I'm going to say, okay, please go ahead into faces, return X, Y, W, and H in every single face. Afterwards, we're going to say, okay, CV2 dot rectangle. I want to draw the rectangle, right? And I want to draw the rectangle on my image color. And every time I'm going to pass along my X and Y, which is a top left coordinate. And then I'm going to say, okay, let's return X plus width and then y plus the height. This is plus, my apologies. And then here we're going to specify the color too. So I'm going to say, okay, 0, 255, and let's say 255. And then maybe we can make it, let's say, thickness with 3. And then afterwards, once we do that, then we can go ahead and actually plot our image. So we're going to say cv2.image_show. And here we can call it multiple face detection, or multi-face detection. And I can pass along my image underscore C, which is the image along with all the rectangles drawn on top of it. And then please again, don't forget to add cv2.weight key. And afterwards, after we exit the loop, make sure that you include as well cv2.destroy all windows. All right, that's it. Let's take a look. Let's actually test it. So let's run that. So this is again my colored image, looks good. Let's run this, we should take all the faces, and let's do this. All right, so it's telling me something is not right. CV2 is not defined. Yeah, my apologies, should be CV2. So again, we're stuck in the loop. Let's close the program. Okay, the kernel is dead. Let's go back again and run OpenCV because that's what we need first. And let's go down here and run it. Okay, so now we have my image again. Okay, let's zoom in a little bit too. We're going to run the classifier, looks good. And let's run this afterwards. Okay, another error. So it's telling me CV2 has no attribute weight key. So here weight key K here has to be uppercase. Again, my apologies. You guys might be running through all these problems already. So let's close the program, close it again, and let's run it again. So let's run. Okay, kernel has died. Okay, so let's run it again. Shift enter, looks good. Let's go back here, run it. Here we go, my image. We're going to detect the faces. Looks good. And let's go ahead here and run it. And here we go. So finally, so here, as you guys can see here, let's show you. You will find that this is simply my first face that has been detected. Okay. All right. If you press enter, you find that every face starts to appear, right? So we have another face here that appeared. Enter one more time, another face, another face. It's really amazing, another face, because it's detecting every single. This is a false, so which means that maybe I need to increase the number of neighbors, maybe from 5, make it, let's say 7 or 8 maybe. Again, you guys, there's tons of improvements that can be done here. Another face, amazing. So again, this is kind of like a repetition probably. One more time, detecting all the faces. Okay, looks good. And that's it. So it actually missed, I think it missed already 2 faces, which is, still not too bad. Let's actually go back here to our notebook. All right. And that's it. That's pretty much all what I have for this lecture. I hope you guys enjoyed it. Please go ahead and pause the video and maybe try to change this, for example, from 1.1, maybe change it to, let's say, 1.3 or 1.4, okay? And change this, for instance, from 5 and make it, let's say, 7 or 8. And again, please go ahead, try different numbers, maybe pick 2 numbers and let me know if you realize any difference in your results or not. Please go ahead, pause the video, and I'll see you guys after the challenge. All right, I hope you guys were able to figure out the challenge. What I ask you guys to do is to go ahead here and maybe try to tune the colors here, or the thresholds here. So I just went, I picked maybe 2 samples. You guys are free to pick whatever. So what I tried first is maybe set to 1.01 and 5, okay? So if you guys remember, before it was 1.1 or 1.2, which means we're scaling it to 20% or 10% of its value, and then 5, right? Which means I need 5 at least maybe neighbors to detect. What I did here is just maybe change it to 1.01 and 5. So when I say 1.01, that means I'm just going to scale it every time into 1%. That means you're going to have tons of pyramiding. So I'm going to have like, 100% image, and then, like scaled by smaller by 1%, and then by 2%, 3%, and so on. And here I'm going to keep it to 5 as well. Let's see how that will going to impact. Please make sure that before running this, make sure that you load the image again to make sure that you clear all the rectangles from previous step. Shift enter, looks good. All my image, new image, right? Here, 1.01, it's taking a little bit more time, which makes sense. Then shift enter, and here we go. So you guys can see here first that because now I'm scaling the image to much smaller, you might find that a lot of like false rectangles have been detected. So press shift enter. So see, this is detected this as a face, which is a joke. And then go down, this is a face. It's his tie, for example. Why? Because here I'm looking for kind of, like smaller ranges as well, right? So I'm missing a lot of information. So see, so just maybe one right face here, couple of right faces, but there's a lot of like error, lots of mistakes, right? The tuning of these parameters is actually very critical, right? Okay, so I've been detecting faces, right? So, which is good, but it's a lot of errors, right? See, so simply here in this algorithm, I was actually been able to detect all the faces. So 1, 2, 3, all of them, pretty much. At the same time, this comes with a cost, right? It comes with a cost that I've been detecting garbage here a lot of where. Like all this, I don't need it. I don't need to see that, right? And even like this one is even another mistake too. So detecting tons of mistakes, but I've been able to detect lots of faces. However, if I go back to the original settings, if I'm going to set it to 1.1, if you guys recall, and let's run it again, let's load the new image. And let's go and come here and load the new image too. And let's detect faces. You'll find that we have been detecting faces. It's actually pretty accurate, pretty amazing, right? Yeah, maybe one mistake here, but we didn't get lots of mistakes in there, which is good. Detecting faces, but it comes with a cost too. What's the cost? The cost is I missed a couple of faces. I'm gonna show you. So right now we have 3 faces missing, right? So we got this, and then we missed 2 faces, right? So we need to have kind of, try to find that sweet spot. What's the best value that we need to put here to be able to obtain all the faces and minimize all of the garbage in there, or minimize all the, we'll call it false positives or maybe false negatives as well within our image. All right, let's try one more sample. I set it here to 1.1, and instead of having 5, my apologies, which is 5 neighbors, I need just to set it 1, which means whatever you guess in one single, like rectangle that there is a face, let's take it. Okay, let's run it. Let's run that one. It's good. And let's run that one. And here you go. You'll find tons of, like random points, because there is no validation. There is no like a confirmation from other samples. So we're again detecting a couple of faces, but there's again more mistakes. Look, there's tons of mistakes here too, and so on. Okay. All right, and that's it. That's pretty much all what I have for this lecture. I hope you guys enjoyed it. In the next lecture, we're gonna do a little bit more exciting stuff as well. We're gonna detect eyes and faces within our image. I hope you guys enjoyed this lecture, and see you in the next one. Hello everyone, and welcome to this new lecture. In the previous lecture, we were able to detect multiple faces within an image, and we've been able to apply that to detect many faces of our favorite scientists. So let's actually run that again to make sure that you guys are following. So we're able to actually detect, this is the image for our scientists, and we're gonna go ahead and detect multiple faces. So if you guys remember that, let's actually exit this. So I'm gonna press enter to exit. And then here we're gonna specify this as 5 instead, and press shift enter, and here shift enter. And we'll be able to detect basically all the faces in here, which is pretty amazing, right? Yes, we have missed a couple. Yes, maybe we have misclassified something here, but that's fine. The idea is amazing. All right, okay. In this lecture, we're gonna go ahead and actually start to detect eyes and faces. Let's see how can we do this. So we're gonna say, okay, image underscore C equals to cv2.imageRead, and here we're gonna pass along our Trudeau's image. All right, let's shift enter, looks good. And that's the mainly the, I don't want to say challenging part, that's the new element here. what I'm going to do here, I'm going to have two classifiers. The first one is my face classifier, which is equals to cv2 dot cascade classifier. And here, what I'm going to do, I'm going to load our har, if you guys remember, har cascades. And within har cascades, if I actually do tab, they're going to tell me there are two classifiers, right? One of them for the I, and that's what I'm going to do it for the, my apologies. So actually the first one, this I, I'm going to do it for the I classifier. So I'm going to go here and call this I classifier. I'm going to have another classifier, just copy and paste. And instead of I, I'm going to call it face classifier. And here, instead of having this, I'm just going to go back and do tab, and it will tell me there is one, there is har cascade frontal face default. If you guys are confused, please don't. So I guess if you guys remember, in the course package, you will find that there is har cascades. If you open it, that will show you here that we have these are two kind of trained classifiers. All right, they are already trained to detect faces, they're already trained to detect eyes, and here we go. All right, let's go ahead and see how can we simply detect this in an image. So first of all, we're going to detect faces first. So we're going to say, okay, faces equals to face underscore classifier dot detect multiscale, and I'm going to specify, okay, I am looking for image C, and I need, let's say, scale 1.2, and I need neighbors to be 5. We have done that many times before. And then we're going to create a for loop for every time I'm going to pass along my X, my Y, my width, and my height too. And we're going to say in faces. And every time I'm going to go ahead and do cv2 dot rectangle. And I'm going to pass along here my image underscore color, right? And every time I'm going to get the coordinates, which is the top left coordinate and the width and height of the rectangle. I'm just going to go ahead and actually draw it, right? So I need 0.1 and 0.2, if you guys remember. So here I'm going to have 0.1, and then here I'm going to have 0.2, and then here I'm going to specify the colors, and here I'm going to specify, let's say, 3, which is the thickness of my line. So you're going to say, okay, X and Y, and then here I'm going to say X plus W, and Y plus H, and here I'm going to specify the color, let's say 0, 255, and 255 afterwards. All right, and then afterwards, we'll go ahead and actually visualize it. So we're going to say image show. We're going to say, let's say Trudeau. Here I'm going to call it face and eye detection in color. And here I'm going to pass along my image underscore C. Afterwards, please don't forget this, please, cv2 dot weight key. All right. And maybe we can just leave it like this. And then afterwards, so what we have done here simply, we have just detected the face. So every time I'm just gonna go get the face, and here we go, right? Now to the challenge, I want to say challenging part, now to the new part. What I wanted to do here is I wanted to get my region of that face. So what I'm gonna do, we're gonna say, okay, let's grab that face, because simply when I wanted to apply my eyes classifier, okay, I don't want to look for eyes in the sky, right? I want to look at an eyes within a face. So if a face is detected, let's go ahead and extract that region, which is these coordinates from our image, and look for eyes in it. That's the overall idea. Okay, so first of all, I'm going to say, you know what, I'm just going to skip this step. I'm going to say, okay, let's select the face region. Okay, I'm going to skip it, okay? What I'm going to do, I'm going to apply my eye classifier, the exact same fashion. I'm going to say, okay, all the eyes that have been detected is eye underscore classifier. I'm going to say dot detect multiscale. And here I need to pass simply my region. So whatever face I'm going to be selecting here, I haven't filled it out yet. But here let's call it face region. And here face region has to be something, right? So face region, I'm going to tell you exactly what they mean by face region. Equals something. I'm just going to leave it for now. What I did here, I just got the face region, right, and put it into eye. Okay. All right. So here I detected every single eye. And here we go. It's what we're gonna do here. We're gonna do the exact same stuff, exact same code, this exact same code. I'm just gonna copy it and paste it here. Every single step is pretty much the same. The only difference is, and we're not gonna detecting faces, right? I'm detecting eye. So I'm gonna go ahead into every single eye that has been detected. Here I'm gonna call it IX, I'm gonna call it IY, I'm gonna call it IW, and I'm gonna call it IH. Every time I'm gonna take my, here, instead of having the image, I'm gonna be doing this for the face region, right? It's the exact same face region. I'm gonna take the face and draw the eyes on it. So which eye with all these coordinates, right? So here we're gonna have I underscore X, I underscore Y, and I have I underscore X, I underscore W, I. All right, looks terrific. And here we're gonna show as well true to face, and then here image color, weight key, and please don't forget to destroy all windows. And the only missing, so basically this is our code, right? So we're gonna detect faces, and within the face, I'm gonna go ahead, detect eyes, call the eye classifier, and for every eye, I'm gonna go ahead and actually perform a loop. Please make sure that this is all tabbed because this is the body of the 4, right? And this has to be in line with this because every time I'm gonna go ahead and actually detect the face, I'm gonna go here and detect all the eyes within the face. That's the overall idea, right? Because I have more than one eye in a face. Think of it as nested loops in a way. It's a great practice for our nested loop part of the course. So here, in order to access this specific image, what I'm gonna do, I'm gonna say, okay, if you go to my image color, which is my image, I can go ahead and actually grab my region, this region. So I'm gonna say, okay, go ahead into Y, from Y till Y plus H, and from X till X plus H. This is simply, or W, basically here W and H were pretty much equal, but please make it like this. So we're gonna say, okay, let's go ahead into my Y to Y plus H, which is, like from the height of my image, X plus W, which is my width of my face, sorry, not my image, my face, just the region of that face. Extract this from my original image, and that will be my face region. All right, and here we go. Okay, and then within that face, let's take a look at the eyes. So within the face, look at the eyes, and when you detect all the eyes, grab all the coordinates of all the eyes and draw them on the face. That's the overall idea. Okay, all right, looks great. So let's take a look at it. So let's press Shift Enter, and here we go. So now I detected the face. Okay, that's a good sign. Press Shift and press Enter. First eye, second eye, amazing. And here we go, it exited. That's great. So now I've been able to actually detect the faces and detect the eyes. Maybe you guys can go ahead here and change this, for example, into, let's say, 0 instead, so you can have different color for the eyes. Let's run it one more time. Actually, so what happened is here, it detected again another face, detected another eye, but the problem is, okay, that's actually a very good point, because first of all, we didn't load the original image. We are overwriting the image that has already the rectangles, right? But you guys can realize here, yes, we detected a rectangle, we detected again here rectangles with different colors, but they are a little bit shifted, which is good. That means the algorithm, is actually kind of smart in a way. It's not, it's not repetitive. It's not like memorizing in a way. It's actually detecting kind of, several times, detecting pretty much the same region, a little bit shifted, but that's fine. Okay, actually there's one mistake here. Okay, we don't need this. So there is a misclassification. So what we could do again, let's go ahead and actually load the image first, load the classifiers, and run it again. Here we go, one face, one eye, and here we go, 2 eyes, perfect. All right, and that's pretty much all what I have for this lecture. I hope you guys enjoyed the entire project. And now it's time for a mini challenge. I want you guys to pause the video and please go ahead and change this. Instead of 1.2, maybe try 1.5, for example. And let's say here, instead of, and maybe try 1.05, like smaller number. Let's see what's gonna happen. And instead of 5 here, maybe select like 1, for instance. And please go ahead, pause the video, and I'll see you guys after the challenge. All right, I hope you guys were able to figure out the challenge. What I ask you guys to do is to simply go here, and I tried maybe a couple of numbers just to show you guys. So first, I tried 1.01, okay, and 5. Okay, so instead of 1.2, I believe was before, let's set it to 1.01, and let's see what impact we're gonna have. Let's run it, run it, run it. Here we go. Enter, enter, looks good. And it looks like nothing has changed. That's good. That means, even if we change the scale to, let's say, smaller numbers or maybe larger numbers, it didn't make much of a difference. But what we could do here, if we change the neighbors, for example, from 5, which means I need kind of, more votes, from 5 neighbors, here I'm going to set it to 1. And let's see if what impact was that going to do. Let's press Shift Enter, Shift Enter, Shift Enter. Here we go. And you guys can see that we detected eyes, that's good. But there's a lot of mess ups. So I detected a new face here. Another new eyes, another face, it's like random basically. So obviously this parameter is very important, very sensitive. So please make sure that you need again for number from 3 to 6 at least to actually make sure that there is repetition, that there is neighbors, there are many faces, many pixels have to say that there is a face in there. So I'll be able to detect it. And here we go. Looks great and great job. I hope you guys enjoyed this lecture. Let's recap what we have done so far in this project. We have been able to detect one single face within an image. We have done that, it was amazing. And the next one, we have been able to detect multiple faces within an image. In our scientist image, we're able to detect all of them, and we have realized that these parameters are actually very important, the neighbors and the multiscale too. And then the learning outcome 3, we're able to detect eyes and faces as well. We have been able to practice some of the for loops skills and some of the nested loop skills as well, along with the OpenCV, along with tons of learnings. I hope you guys enjoyed this lecture and enjoy the entire project, and I will see you guys in future projects.